I'd like to speak to you today about a new high-definition portable lens, unique in that it is the world's first high-definition lens with built-in optical stabilization. Let's talk about stabilizing an image in a lens and camera. You get a very sharp, stable, high-definition image in your video from a lens and camera and camcorder when the optical image from the lens is projected squarely onto the image sensor and is absolutely stable on that sensor during its exposure time. If, for any reason, the lens and camera jolts or vibrates horizontally, vertically, those light rays can be deflected as they enter the camera. The camera sensor does not know that. It simply scans orthogonally, and of course you would then produce a video that will be moving with inadvertent movements or vibrations or a slight blurring of the image unsteadiness, very unpleasant, particularly with high-definition imagery. Now, these perturbations that I speak about can be caused by many things. Hand-holding a lens and camera. A good operator can hold a lens camera very steadily. Shooting over protracted periods of time, fatigue can set in. Maybe small tremors come in or a slight movement. Shoulder mount, the same thing, very stable on the shoulder. But again, over periods of time, fatigue might cause some tremors and movements. Of course, if it's shoulder mount or handheld and the camera operator is walking, as they must for certain types of shoots, or running, obviously that is going to exacerbate the perturbations. The lens camera might be mounted on a tripod. Very stable under normal conditions, but perhaps the tripod's mounted on a platform or a tower that's vibrating, or there's a strong wind blowing. So there's many, many conditions that can not be overcome directly by the camera operator. And that's where image stabilization is required. Now, image stabilization over the years comes in really three forms. One is the mechanical approach, gyro-stabilized casings that house the entire lens and camera and protect it from external disturbances. Works very well, can be slightly expensive, but for many applications it might be the only way. The other way that we see more recently is electronic, done in the camera or camcorder, where the video that's emanating from the image sensor is analyzed, and if unwanted movements are seen, then a correction takes place electronically. It can be of two forms. It can be a feedback that resamples the image sensors themselves in a manner to counter the shifts of the spatial image on the sensor, or a little downstream in the camera where you have the digital red, green, blue videos. You can analyze those and resample digitally to offset the disturbances. And then the third system is the one that I will be describing today, and that is the optical, built into the lens. In launching the development of the built-in optical stabilization, it was first necessary to do a considerable amount of work in identifying details of the problem itself. Specifically, when we talk about unsteadiness in a lens and a camera, we're interested in the amplitude of the perturbation, the direction of that perturbation, is it horizontal or vertical, or both, and the frequency of those movements or vibrations. And it turns out that, in general, with hand-holding a lens and camera, you're talking about movements around the 1 hertz. If you shoulder mount the lens and the camera and you're walking, you might move up to 1 to 3 hertz. Running, up to 4, perhaps 5 hertz. If the camera is mounted on a tripod, which should be very stable, except that the tripod's mounted on a platform that can vibrate, or it's up in a tower that can vibrate, then we can encounter frequencies that might be from the 4 to 6 hertz. And last, of course, very important, hand-holding a camera, perhaps from the pillion of a motorcycle, or shooting from a car, or a helicopter, aircraft, a boat, where there are movements and vibrations. Now we might encounter frequencies that maybe range from the 5, 6 hertz up to 11 or 12 hertz. So it's a relatively narrow range of frequencies that must be dealt with. And that, of course, constituted a core element in the design of the optical stabilization system.